Hi, everybody. Let's do IXL 8th grade I.5. Go to Learning. Make sure you're on Math. Go down to 8th grade. And then down to I.5. Write equations for proportional relationships from graphs. Okay, let me make this smaller. All right, so I'll read this. I'm not going to read the story for every single exercise, but I'll read it for the first one. Healthy Grains is an organic food company that makes several different kinds of trail mix. The company's sweet and salty trail mix includes dark chocolate and almonds. That sounds tasty. And it comes in different sized packages. There is a proportional relationship between the amount of dark chocolate in ounces X and the amount of almonds in ounces Y. So on the x-axis here, this tells us how many ounces of dark chocolate we have. And the y-axis tells us how many ounces of almonds we have. So for example, if we look at this point over here, it's telling us that if we have a candy bar with 2 ounces of dark chocolate, then it will have 6 ounces of almonds in that candy bar. Moving back to the story. Oh no. So that was the whole story. So write an equation for the relationship between x and y. All right, so basically, we see from the graph here, when there is 1 ounce of dark chocolate, there are 3 ounces of almonds. When there are 2 ounces of dark chocolate, then there are 6 ounces of almonds. When there are 3 ounces of dark chocolate, then there are 9 ounces of almonds. And we also have these decimal values in the middle. And of course, this arrow indicates that we will have this relationship going on with higher numbers also for the ounces of dark chocolate versus the ounces of almonds. So can we put the information that the graph is giving us into the form of an equation that will actually tell us the same information? It will just be in a different form. And we can do that. To see how, let's go over to Frydman Math, and this is page 14. So make sure that you go down to page 14. Actually, in the table of contents here, it says that converting between representations of proportional relationships is on page 14. So scroll down there. Here I am again, page 14. Okay, so this is what we want to look at right here. We are starting with a graph, and we want to convert that into an equation. And it would actually be the same strategy if we started with a table and converted it to an equation. So they're both in the same box here. Step 1, pick any point, meaning a pair of values. So we have 2 values, right? In this case, 1 value for the dark chocolate, for the ounces of dark chocolate, and 1 value for the ounces of almonds. So we pick any point on the graph, which is actually a pair of values, and use the numbers to set up a proportion. Step 2, we divide the numbers. Step 3, we multiply both sides by the remaining denominator. So here's an example using the values of 3 apples and 6 coconuts from the previous box. So you look at the previous box over here. Here's the previous box where we have this graph here and also this table. And we can see, it's a little small here. I can make it bigger. According to this graph, 3 apples corresponds to 6 coconuts. So using that information, and I know that the relationship is proportional because it's a straight line going through the origin. The ratio between the values is always the same. So using that information, we can actually figure out the equation just by setting up a proportion. So C for coconuts, A for apples, and then it was 6 coconuts. So I'll put the 6 in the numerator because the C for coconuts was also in the numerator. And it was 3 apples. So I'll put the 3 in the denominator because the A for apples was also in the denominator. Okay, step 2, we can just focus on the right side of the equation and just forget about the left side for a second and just divide these numbers. So 6 divided by 3 is 2. So now our equation looks like C over A equals 2. And then as our last step, to get the A away from the C, we can just multiply both sides by A. So if you see in step 3, if we multiply the left side by A, there is the A right over, whoa. There is the A over here, and we multiply the right side by A, then this A and this A cancel out, and our equation is just C equals 2A. So that would be the final answer for that example over here. Now let's go back to IXL and see if we can use the same strategy for this question. So we're just going to pick any point except 0, 0. Do not pick 0, 0. Any other point is fine. So how about this point over here? And I will let, well, let's see what IXL said. Okay, so they said Y and X. Okay, so our Y coordinate, well, basically, let me write Y over X over here. Now, our Y coordinate, right, is, that was the Y coordinate, is 6. And the X coordinate was 2. And we can do 6 divided by 2 is 3. So let me rewrite the whole thing as Y over X equals 3. And then I'll just multiply both sides by X. And that cancels out there. And then we have Y equals 3X. And that is our answer. And I could just, I'm sure you want me to just plug that into IXL right now and be done with it. But I like to actually show that this equation does really make sense for this graph. And to see that, we can plug in some numbers. So for example, we can take that equation, Y equals 3X, and what would happen if we plugged in the 6 for Y and 2 for X? 6 for Y, 2 for X. Then we get 6 equals 3 times 2, and 3 times 2 is 6, so we get 6 equals 6, so that works. And that would also work for other values. So what about this point over here? That would be, I did a really bad job of drawing that dot, but okay. That would be 9 for Y and 3 for X. Let's see if that works. Y is 9, X is 3, and I'm also copying this 3, so I have 3 times 3 on the right side. So I get 9 equals, and 3 times 3, of course, is 9. So I get 9 equals 9. So that's good. So this equation is actually giving me the same information as this graph, meaning I could use this equation to figure out what points should be on this graph simply by plugging numbers into the equation. And if the numbers work out, then the point should be a point on this graph. And if the numbers don't work out, then the point would not be on the graph. All right, so our equation is Y equals 3X. So let's type that in and submit. Let's do another example. So we'll pick this point over here. You really want to make sure that the point that you're picking, so notice that the whole graph looks like a whole lot of plus signs, right? Like here's a plus sign, and here's a plus sign, and here's a plus sign, and here's a plus sign. Of course, these are not on the line. We really focused on the blue line here. So here's a plus sign, for example, and the line is going through this plus sign right over here. So that is a point that we can pick. You want to make sure that the point that you pick is on a plus sign. So for example, this over here, this point over here, is on the line, but it's not on one of those plus signs. So this would not be a very good point for me to pick. Like this is a plus sign over here. This is a plus sign over here, also right next to it. So this point is not on either of these plus signs. So this point is not a good point for me to pick. But this point is on a plus sign, so that's a good point for us. And now we'll just look at what the y-coordinate is. That's a 6, and the x-coordinate is a 1. So we can say y over x equals 6 over 1. 6 divided by 1 is just 6. So we have y over x equals 6. And then we'll multiply both sides by x, and that cancels, and we get y equals 6x. That's it. All right, this looks to be the same. I'm going to jump a level, see if I get something different. All right, this is also the same. Let's do one of these real quick. So here I see that this point is on this plus sign, so that's a good point. All right, so that's 15 for y, and it's 5 for x. So let's do y over x equals, what was it, 15 for y, 5 for x. You want to make sure that you're consistent here. So I put y in the numerator, so I should put my y value also in the numerator. And I put x, I put x in the denominator, so I should put my x value, 5, also in the denominator. All right, so 15 divided by 5 is 3. So we get y over x equals 3. And then multiply both sides by x. Y equals 3x. And if you wanted to check that that works, you could plug in 15 for y, 5 for x, right? And 3 times 5 is 15. So we get 15 equals 15, so that works. So that's a good equation for this graph. What was it? 3x. Okay, this is also the same. I'm going to skip ahead. I have a feeling they're all going to be the same. Yeah, so this is also the same. Maybe the numbers are a little bit bigger, but oh, no, here. Okay, so it's asking us a different question. Do x and y have a proportional relationship? So that is a different question. Now, also, I'll go back to the reference pages and let me look at page 9, which has proportional relationships on it. Here's page 9, proportional relationships. So the definition of proportionality: two quantities are in a proportional relationship if the ratio between them is always the same. And the way that we check very easily if two quantities are in a proportional relationship is we have to make sure that the line is straight and it goes through the origin. So it has to be a straight line going through the origin. So over here, this is a straight line and it goes through the origin, which is 0, 0. So this corner point over here. So yes, this would be a proportional relationship. Okay, now that we know that it's proportional, we can use our proportion strategy to figure out the equation that goes along with it. So, and this we've done before. So let's pick a point. Here's a point, good point right over here. We have 20 for y, and we have 1 for x. Y over x equals 20 over 1. 20 divided by 1 is just 20, so we have y over x equals 20. Multiply both sides by x, and we get y equals 20x. Okay, do x and y have a proportional relationship? For this one, we see that it is a straight line, but it does not go through the origin. We want the line to go through the origin for it to be proportional. This line does not go through the origin, so we're going to click on no. That is not a proportional relationship. Okay, again, it does not go through the origin, so we're going to click on no, not a proportional relationship. And this one, it is a straight line, and it is going through the origin, so this one, we'll click on yes. It does show us a proportional relationship, and I'm not going to do the equation right now because it's the same as all of the other ones. So I'm just going to skip a level and see if we get a different kind of question. Okay, so this one is telling us the same thing. I could do here 60 divided by 5 is 12. So this would be 12x over here. All right, so all of these seem to be the same type of question. So I'm going to end the video there. I hope that was helpful. Please reach out if you have any questions, and have a great day.